All right, let's get into it. Today, we are cracking open one of the greatest scientific detective stories ever told. It's a mystery about the very ground we're all standing on, a puzzle that took centuries to piece together, full of lost continents, strange fossils separated by entire oceans, and a massive secret that was hidden deep beneath the waves. So let's start putting the pieces together.
Have you ever just stared at a world map and noticed something kind of funny about the coastlines? How South America seems to just perfectly tuck into the side of Africa, like they're two giant pieces of a jigsaw puzzle that got pulled apart?
Well, get this. That is not a coincidence. Not at all. In fact, that simple little observation is the very first clue in a story that would completely revolutionize how we understand our own planet. So, our story really kicks off with that puzzle on the map. For hundreds of years, people noticed it, map makers, scientists, you name it. But it was mostly just, a neat little curiosity. That is, until people started to seriously wonder, what if they were once actually connected? They started to imagine a time way, way back, about 200 million years ago, when all the continents we see today were smashed together into one single enormous supercontinent. They gave it a pretty epic name, Pangaea. It's Greek for all Earth.
Okay, but an incredible idea is one thing. Proving it is something else entirely. And the man who really built the case for this was a German meteorologist, of all things, named Alfred Wegener. Back in 1912, he put forward his theory of continental drift, and boy did he bring the evidence.
First off, Wagner pointed to the most obvious clue, right? The jigsaw fit. It was just so convincing. So much so that decades later, long after he was gone, a computer model in 1964 confirmed that the fit along the continental shelves was, in fact, nearly perfect. Next up, Wegner found what was basically a geological fingerprint. There's a belt of really ancient rocks, about 2 billion years old, that runs along the coast of Brazil. And wouldn't you know it, it matches up perfectly with a similar belt in Western Africa. It's like a single mountain range was just torn in half. Then came the fossils. This one's a classic. The remains of this small, land-based reptile called Mesosaurus have only ever been found in two places on Earth, South Africa and Brazil. Now, this little guy could not have swum across the entire Atlantic Ocean. No way. The only possible explanation was that these two places were once joined. And maybe the wildest clue of all was all about the climate. They found clear evidence of massive glaciers, the deep scars and rocks they leave behind, in places that are now scorching hot tropical areas like India and parts of Africa. Now, how on earth does that make sense? Well, it only works if those continents were once all huddled together down over the South Pole. So Wegener had this mountain of evidence. He could prove that the continents drifted. But, and this was a huge but, he had a massive problem. He couldn't explain how. I mean, what incredible force could possibly be strong enough to push entire continents across the face of the Earth? Wegener took a guess. He suggested maybe the Earth's rotation or the pull of the moon did it, but physicists ran the numbers and pretty much immediately said, nope, not even close. Those forces were nowhere near powerful enough. And because he was missing that crucial piece of the puzzle, his brilliant theory was basically rejected, even laughed at for nearly 50 years. So the case went cold. The trail just stopped. But then, in the years after World War II, new technologies like sonar gave scientists the ability to do something they'd never done before, actually map the ocean floor. And what they found down in the dark? Well, it changed everything. Turns out, the ocean floor was not some flat, boring, muddy desert, not even close. There was a massive 65,000-kilometer-long volcanic mountain range snaking around the entire globe. And even crazier, the rocks on the ocean floor were super, super young. And they were youngest right at the peak of this ridge and got older the farther you moved away. What was going on here? So in 1961, a geologist named Harry Hess put these brand new clues together and had this incredible aha moment. He proposed this revolutionary idea called seafloor spreading. He figured that the continents weren't just plowing through the ocean crust. No, the entire seafloor was moving, and it was carrying the continents along for the ride. The whole process works just like a giant geological conveyor belt. At those mid-ocean ridges, new crust is constantly being made as magma pushes up. This new rock pushes the older seafloor outwards. And then, at the edges of the oceans, that old crust sinks back down into the earth at these super deep trenches and gets recycled. This This was the powerful engine that Wegener had been looking for. And with that final, critical piece of the puzzle finally in place, scientists were able to combine Wegener's idea of continental drift with Hess's seafloor spreading, and they created one grand unifying theory. In 1967, the theory of plate tectonics was born. So here's the big idea. The Earth's hard outer layer isn't one solid piece. It's actually broken up into about a dozen massive, rigid slabs called tectonic plates. So the continents themselves don't just drift around on their own. They're more like passengers, riding on top of these huge moving plates.
And pretty much all the geological action, we're talking earthquakes, volcanoes, mountains, it all happens at the boundaries where these plates meet. Where they pull apart or diverge, new crust gets created. Where they smash together or converge, crust gets destroyed, which is how you get huge mountain ranges. And where they just slide past each other, you get transform boundaries, which are famous for causing earthquakes.
Now, the most important thing to remember is this. It's not just ancient history. It's not over. The plates are moving right now, at this very moment, constantly reshaping the face of our planet.
Just take the incredible journey of India, for example. It broke away from Pangaea, spent millions of years as an island continent just booking it north, and then finally, bam, it slammed into Asia somewhere around 40 to 50 million years ago. And that collision is still happening today, pushing the Himalayan mountains higher and higher every single year.
And these movements all happen at different speeds. Some plates just crawl along, moving slower than your fingernails grow, less than 2.5 centimeters a year. But others, like the plate out on the East Pacific Rise, are absolutely racing along at more than 15 centimeters a year. Yeah, you heard that right, more than 15 centimeters in a single year. It just goes to show you that our seemingly solid planet is actually this incredibly dynamic, breathing world in constant, powerful motion. So the great Earth puzzle that Wegener started, it's been solved. But the story itself is far from over. The plates are still moving, that great conveyor belt is still turning, and that leaves all of us with one really fascinating final question to chew on. Where will the continents be in another 200 million years?